Hi, and welcome to another version of what's going on in physics. Now, we're looking at forces still, and this is a common thing, and it's actually called a Newton's cradle. And we can actually see how the force is knocking one off the other end as it hits down, and then this continues going. It's a wonderful little toy, but it's all about Newton's laws. Now, Mr. Newton, or Isaac Newton, was a scientist a few hundred years ago, and what he did was he came up with some ways of explaining what was going on in terms of how things moved, and his laws we still use today. Right, with his first law we look at what's called status quo. Now, status quo remains the same. And you see the lovely little picture I've got here with the giraffe in the car, and when it hits the wall, the giraffe tries to stay the same, but its neck is pushed forward because that's the way it was moving until the car hit the wall. So, what Mr. Newton did to explain this was he decided that things would not move unless we made them, and that meant we had to use a force. Right? So any change we were going to cause was caused by a force. But we have to think about it not only in not moving, but as we can see in the car with the giraffe is moving with the car. Alright? And when the force goes back, the giraffe keeps wanting to move forward. Now, of course, the poor old giraffe is going to hurt its neck big time here. But that is in essence what is going on. So he said, Mr. Newton said, that things will stay still or keep moving the way they were moving until a force acts on them. Alright, so with this, we actually call that the ability for something to stay still. We actually give it a special name, inertia. Now, that's like when you're sitting on a chair or you're sitting somewhere. Then there's no real force acting on you, so you stay still. But really there is a force acting on you. Gravity's still there, and we've got a couple others there, but it doesn't really matter. So we're seeing that big objects, right, will move, will have a bigger force and be able to cause bigger motion, if you like. Now, over here on the trampoline, we've got the person going down through the leaves. Now, look at the way the leaves stay where they are until gravity drags them down, and then they strike the netting again. Now, it says here that big objects are hard to get to move, and anyone who's ever tried to push a car will realise that. So we're going to use a very large force. Now, this large force we need can be caused by a big mass. Now, mass is to do with the amount of particles in it. Alright? If we are living in an area where the gravity is high, then gravity is going to try to stop us moving. And the third thing that's going to try to stop us moving is friction. And as we've seen, that's when two things rub against each other. Okay, let's move on to the last little bit. So, if we say this is going on, then we can relate this back to what we did before in terms of speed and acceleration. So, a force is causing an object to either speed up or slow down. So, in other words, it's changing its speed. Now, we learnt before that if we change speed, then we are using the word acceleration. So, to finally come up with what Mr. Newton said, he said that the force will cause the object to accelerate or change the way it moves, change its speed. Alright, and as we can see by this person on the motorbike, he is doing all sorts of things, but there are forces pushing and there are forces pulling to try to make him move. On that, we're going to stop.